Day 268 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 33, search and rotated sorted array. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and go ahead and get you some, y'all. Now, let's see what the question says. Question says, there's an integer array num sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k where 1 is less than or equal to k and k is less than nums.length such that the resulting array is nums k is nums comma nums k plus 1 all the way up to nums n minus 1, nums 0, nums 1 all the way up to nums of k minus 1, 0 index. For example, the array 0, 1, 2, 4, 5, 6, and 7 might be rotated at pivot index 3, which is right here, and become 4, 5, 6, 7, 0, 1, 2. Given the array nums after the possible rotation and integer target, return the index of target if it is in nums or -1 if not in nums. You must write an algorithm with a big O of log n runtime complexity. Whew. All right, y'all, that was a lot to say, but let's get into these examples so we can know exactly what it is that they want us to do. So in example 1, we have the input nums. We have the array of integers 4, 5, 6, 7, 0, 1, and 2. The target is 0. The output is 4. Output is 4 because we could find the target, which is 0. We could find that right here at index 4, right? 0 index array, so means we start at 0. So it goes 0, 1, 2, 3, 4. Find 0, which is the target at output at index 4. Thus, the output is 4. So let's look at example 2 where they might try to throw some trick questions our way, right? So in example 2, we have the input nums equals an array of integers 4, 5, 6, 7, 0, 1, and 2. This time the target is 3. This time, and we put output as -1 because it says right here -1 if it is not in nums. And as we can see, our target 3 is not even in nums, so we're just going to return -1. Same thing with example 3, nums equals an array of integers. That only integer is 1. Our target is 0, and so we're going to return -1 once again because we do not find the target, which is 0, in the input array nums. So now that we understand the question, y'all, let's get into the fun part, the actual code. Code is not that difficult. We should get it through it fairly quickly. So let's get started, y'all. So the first thing we're going to need to do is we're going to initialize 2 pointers for the binary search. We need a left pointer and a right pointer, right? The left pointer will start at the beginning of the array and the right pointer will start at the end of the array. Excuse me. So let's get started with that. So in order to do that, all we need to do, create our pointers, we need to declare a variable we call one left, should be left. We could set that equal to 0. Then we can declare another variable, we could call that right, and we could set that equal to nums.count -1. Boom. Now we need to perform our binary search as long as left is less than or equal to right. So in order to do that, we're just going to say while left is less than or equal to right. Boom. Just like that. Now we're going to open up our brackets. Now the first thing we need to do for our binary search is we need to calculate the middle index of the current range. So in order to do that, we're just going to say let mid equal left plus, open up the parentheses. Then we're going to say right minus left, come outside of those parentheses, and we're going to divide that by 2. Boom. Now we need to see if the middle element is the target. We can just return its index. So we're just going to say if target equal sign nums square bracket, put mid inside of square brackets. So if target is equal to the mid, we're going to open up the brackets and we are just going to say return mid, just like that. Or if So what this is going to do, if target is equal to nums of mid, or nums with a square bracket mid, right? So if nums is equal to the mid value, right? Boom, say, or in this case, 0. So if nums is equal to 0, which is the value, then we just return mid regular, which will return the index. You notice how we don't put the nums and put the mid in the square bracket. We just put mid, because when we just put mid, that's going to get us the index. When we put it num square bracket mid like this, that's going to give us the value of the index. But remember, we just want the mid, we just want the index. That's why we just put mid, because that's going to give us the index, not the value. Now, boom, let's keep going. Now we need to check if the left half of the array is sorted, right, from left to mid. We're going to see if that's sorted. So in order to do that, we're just going to say if nums square bracket left is less than or equal to nums square bracket mid, right? That's going to let us, we're checking to see if it's sorted. Then what we can do, if the target lies within the sorted left half, we need to adjust the right pointer. So we could just say right equals mid minus 1, right? Because we know it's not on the right half, so we could just bring right down to the mid and start from mid instead of going all the way from the right half down. Then we could say else, we're just going to move the left pointer, which is going to get closer to the right, which is going to help us search the right half. So then we're going to say else, we could say left equals mid plus 1. Boom. Just like that, but we're not done yet, because remember, excuse me, this should be over here. Let me bring this over. Sorry, y'all. Or, yeah, sorry. Boom. Actually, my bad, y'all. Delete this right here, because we skipped a step. Let me see. Boom, bring that bracket, make this bracket. We skipped a step because we need to see if the target, right? So this is going to make sure if the left half of the array is sorted up to mid, but we still need to check to see if the target lies within the sorted left half, and then we adjust the right pointer. We're not going to adjust the right pointer unless we know that the target is in that sorted left half. So in order to check that, we're going to say if nums square bracket left, come outside those square brackets. Oh, excuse me. Come outside those square brackets. We're going to say is less than or equal to target. Then we're going to say and nums square bracket mid, come outside those square brackets, is greater than or equal to target. That means we found the target in the left half, and that means now we could bring the right pointer to the mid, right? So then we say right equals mid minus 1. Boom, sorry about that. Now we're going to come down here, and if it's not in the left half, then it must be in the right half, or it might not be, but we're going to check, and we're going to say we're going to move that left pointer anyway, and we're going to move the left pointer to mid so we could go through the right half. So we'll say left equals mid plus 1, just like that. Now we're going to come down to this bracket on this if statement right here. So that's checking if the left half is sorted. So we need to check if the left half is not sorted, then that means the right half must be sorted, because remember, it's rotated. So let's say we rotate this over here, then it's not going to be sorted like it was, right? Let me bring it up here so we go through this, because you see right here it's sorted, but if we rotate it, boom, now this left half is sorted and the right half is sorted, but the whole array is not sorted, right, like it is at the beginning, boom. But remember, it's searching rotated array, so the rotated array might not be sorted all the way. We might have the left half sorted, and then we might have the right half sorted, but the whole thing's not going to be sorted. So now we need to handle the case or to check to see if the right half is sorted. So in order to do that, all we have to do is come right here. We're going to say else, because remember, this checks the left half, see if the left half is sorted. So we're going to come down here, say else, which is going to handle the right half, and we are going to say if the target lies within the sort of right half, then we know we need to adjust the left pointer. So we're going to do the same thing we did up here, just for the right half. So we're going to say if nums square bracket mid is less than or equal to target, boom, and let me see, my bad, and nums square bracket right is greater than or equal to target, boom, then what we're going to do, we're going to open up the brackets, and we are going to say left equals mid plus 1. Then we're going to come down here, and we're going to say else, open up the brackets, right equals mid plus 1. Oh, excuse me, this should be right should be mid minus 1, because remember we're moving the right pointer closer to the middle, so that's why we're going to have to decrement the indexes. Boom, just like that. Now, we're almost done, but we're not done yet, because if the target is not found, then we still need to come right here, and we could just say return -1, meaning if all of this while loop completes, if we go through this whole while loop and we still don't find the target, then we just come right here, then we just come right here and we can return -1. So let's run this, y'all. Hopefully it runs first try. I know it's a little mishaps in there, but ooh, look at that first try, y'all. That's what I'm talking about. It's accepted. So now that it's accepted, let's go ahead and submit it. Make sure it stays accepted after we submit it, because you already know how LeetCode can get. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I like to see. Those some good numbers right there. Now, before we leave, give one more look at the code in case y'all need it. Give one more look at the code. One more look at the code. Boom. It's the bottom. It's the top. Now, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.